Hello everyone. Today we are going to start a new chapter, that is complex number. We're going to start a chapter complex number. So first we want to know why we are dealing with this chapter. So reason behind the complex number is when we see an equation like x square plus 1 is equal to 0. If we see any equation like this, then we will write x square is equal to minus 1. We write it like x square is equal to minus 1. Then x will be equal to under root of minus 1. And we studied in the lower classes that minus 1 is imaginary roots of x, so it is not defined. So in this chapter we will deal about the imaginary roots. We will deal about the imaginary roots whenever in the under root we get a negative number. So how can we will solve this? So Euler's gives the value of under root minus 1. Euler's give this value. So he said that under root minus 1 is equal to iota. He gave the under root minus 1, the value is iota. So imaginary units. In this way we get iota is equal to under root of minus 1. So and iota square is equal to under root of minus 1 ka whole square. So iota square is equal to minus 1. In the same way iota cube is equal to iota square into iota. As iota square is minus 1, iota square is minus 1 and iota is iota. So iota cube is always equal to minus of iota. Iota cube is always equal to minus of iota. In the similar way, iota power 4 will be equal to iota square into iota square. So iota square is minus 1 and iota square again is minus 1. Minus 1 into minus 1 is 1. So in this way we can get any value of iota 5, iota. So if we want to deal about the iota 5, then it will be equal to iota cube into iota square, and iota cube is minus iota square is minus 1, so it will become iota only. So in this way we can find any value of any iota 5, iota cube, anything. So its general expression is iota power 4 n plus r is always equal to iota power r. That is, iota power 4 n plus r is always equal to iota power r. Okay. So if I want to find a value of iota power 9999, so I can write it like at iota power 4 into n is multiple of 4. In this multiple of 4 is, if we find multiple of 4, then it will be equal to 4. When 1999 is divided by 4, we get 490. So 490 and remainder, it will be 16, 39. 39 is not divisible, 36 is divisible, again 3, so again 9, and remainder will be equal to only 3. So its multiple of 4 and 3 is always equal to iota power 3, and iota power 3, as we will studied earlier, that iota power 3 is equal to minus iota. So iota power minus 1999 is equal to minus iota. In the same way, if I have to find the value of iota power minus 1, I can write it like 1 upon iota. Iota power minus 1 can be written as 1 upon iota, and 1 upon iota. In denominator we have to eliminate the iota. So we can write it like that, iota upon iota. We rationalize the iota and it becomes equal to iota upon iota square. As we will know, iota is iota and iota square is minus 1. So iota power minus 1 is always equal to minus of iota. What will we see is iota power minus 1 is always equal to minus of iota. This is the condition. In a similar way, if we have to find the iota minus 2, so I can write it like iota upon iota square, and then I rationalize it. It's iota square, then I write iota square upon iota square, which is equal to iota square upon iota power 4. As we already deal with iota square and iota power, its value iota square is minus 1 and iota power 4 is 1. So it can be written as minus 1 on 1, which is equal to minus of 1. In a similar way, we can find out iota power minus 3. It will be like 1 upon iota power 3, which is equal to 1 upon iota power 3 into iota power 3 into iota power 3, which is equal to iota power 3 upon iota power 6. So it is always equal to is this always equal to, as we deal already in the iota 3 is minus iota, iota 3 is minus of iota. So we can write value of iota 3 and iota 6 and we will get the value of iota minus 3. One more thing, iota power 0 is always equal to 1. Iota power 0 is always equal to 1. Since anything power 0 is, we get answer 1. Similar way, iota power 0 is also. Now let's do some questions based on this. Okay, let's see question number 1. It is, if I have to find the value of minus of root 1 whole power, it's whole power, it's like um, wait, I repeat the question. It's minus of iota whole power 4n plus 3. Now I have to find the value of this. As I know, minus root under root 1 minus of 1 is iota, so it will be equal to minus iota power 4n plus 3. Now we can write it like minus iota power 4n into minus iota power 3. We can write it like this, and anything power 4, 4 is a multiple of this, so anything power 4 is 1, and into minus iota power 3. Minus iota power 3 is iota. So this is the value of question. Now next move to the second question. Second question is, I have to find the value of 1 plus iota square plus iota power 4 plus iota power 20. I have to find the value of this. As I know 1 is 1, then iota square is minus 1, then 4 is plus 1, then next term will be 6, that will be equal to minus 1, next term will be 8, that will be equal to plus 1, and dot dot dot, and at last we got the value 1. So in last all the terms get cancelled out and we will got answer as only 1. Now next property is, if I move to the next property is, if there is root a into root b, as we see in the earlier classes, according to Surt's rule, root a into root b is equal to root ab. Either a or should be positive or 0. It's condition when either a or b should be positive or 0. Only this condition is possible. If I get a case like under root of minus a and under root of minus b, then I write root a is like iota root a and root b is like iota root b. So it became iota square root a b, and root iota square is -1, that will be equal to under root of minus ab. Same way, if I have to move to the questions, then let's do question on based on this question. It's given root 4 under root of -4 under root of negative of 9 by 4. So this can be written as iota root 4, and this can be written as iota of under root 9 by 4, which is equal to root 4 is 2, is equal to 2 iota into 3 by 2 iota. 2 into 2 is cancelled out, we will get 3 iota square. 3 iota square is 3 of -1, which is equal to -3. Let's do the second question. It's under root -25 plus 3 under root -4 plus 2 under root -9. Since we can write it like 25 under root 25 iota, next will be written as 3 iota into root 4 plus 2 iota root 9. This is equal to 5 iota. This is equal to 6 iota. This 3 is 6 iota. Then in short we can write 7 iota. This cannot be simplified more, so we can leave it here only. Now let's think one thing. If, as we know, 3 is greater than 2, so we can't say 3 iota is greater than 2 iota. Okay? So what we therefore inequality is not defined in complex number. Since this is wrong, we can't say 3 iota is greater than 2 iota. Therefore what we get is inequality is not defined in complex number. It is defined only for the numbers, so it is not defined for the complex number. So we read about the complex number, what are complex number and what are all the, okay. So now we will deal about general form of a complex number. As we read a whole about all the numbers, so we will read about the general form of complex number. Okay, general form of the complex number is z. We represent complex number by z, where a plus iota b. General form is z is equal to a plus iota b, where this a is called real part and this b is called imaginary part. A is called real part and b is called imaginary part, and here a and b belongs to real numbers. So this is general. So we can say, we can write real part of z is equal to a and imaginary part of z is equal to b. If any term is purely real, if anything is purely real, then in that imaginary part of z is equal to 0. Example, a plus 0 iota. So it is purely real. And if some equation is purely imaginary, if something is purely imaginary, then the real part of z should be 0. Example, 0 plus 2 iota. So this is the purely real equation. This equation a plus 0 iota is purely real, since in this imaginary part is 0. So we call it a purely real. On in this is purely imaginary, since in this real part is 0 and imaginary part is something. Since real part is 0, so we can call it purely imaginary complex numbers. Now Next is